what we're going to do is take all of the similarity and proportionality theorems that we've learned and now apply them to some more real world situations. So this example says a ladder rests against the top of a wall. The head of a person 5 feet 5 inches tall just touches the ladder. The person is 9 feet away from the wall and 3 feet from the foot of the ladder. Find the height of the wall. Anytime I have a problem like this, I always start by drawing a diagram. So I'm going to start by say, alrighty, here is my wall. I've got my ladder, which of course means my floor is here somewhere. Just like that. And I've got, let's see what information it gives me. The head of a person 5 feet 5 inches tall just touches the ladder. So here's my person. They're standing. And there are 5 feet 5 inches tall. So 5 feet 5 inches. The person is 9 feet from the wall and 3 feet from the foot of the ladder. And they're asking me, find the height of the wall. So that right there is the height. So notice that I've got a right triangle right over here. Okay. And I've also got a right angle right over here, and they share this angle in common right over here. So right now I know that because those angles, I've got two triangles with two angles, and when I take these triangles apart, like I always recommend that you do, you'll see that I've actually got not just two any old triangles, but actually two similar triangles because of angle, angle. All right, so now let's use this information to solve the height of our wall, which is this one right over here. Let's go ahead and transpose all of this information back over. So I know that this is 5 feet 5 inches, and I'm looking for the height, and I know that this small section is 3 feet, and I know that this long section, it's not 9 feet, it's 9 feet plus 3 feet, which is 12 feet. Okay, now notice this right over here is in terms of feet and inches. This is in terms of feet, this is in terms of feet. You never want to work with mixed measurements, okay? Either work all in feet or work all in inches. My recommendation is to work in inches because inches don't they don't translate directly to decimals, right? 5 feet 5 inches is not 5.5 feet. It doesn't work like that, okay? Because 5 inches is not half of a foot. So I always recommend converting it into inches, and that way you don't have to worry about those decimals. So we know that 12 feet is 144 inches. We know that 3 feet is 36 inches. And we know that 5 feet is 65 inches because 5 feet is 60 inches plus my additional 5 inches. Okay, and if you're wondering where I got those numbers, I'm just multiplying them by 12 because I know that there's 12 inches in a foot. So now I just have to set up my proportion. I'm solving for my height, which means this height and this person's height are going to match up, are going to be proportional to this distance and this distance. So let's say height over 65 inches equals 144 inches over 36 inches. And now I just have to solve for the height. So I say 36h equals 9,360 inches. And then I divide both sides by 36, which means that the height of the wall is 260 inches. Or I could say, or 21 3/4 feet. So since it's a word problem, I always want to answer in words. So I'm going to say the height of the wall is 21 3/4 feet. Or if I wanted to get real fancy, I could say 21 feet 8 inches because 8 inches is 3/4 of a foot. And that's all. So it's basically everything that you've been doing, except now we're creating our own diagrams as opposed to being given those diagrams.